Okay, I would like to show people why it's important to understand a bearing application as opposed to just buying bearings by size. This is an upper wheel cylinder shaft for a Poitras 24-inch bandsaw. And it's a pretty simple arrangement. It's a piece of cold rolled steel. You can see the outside. There's a bearing seat that is going to hold your bearing. And this little part right here is going to shoulder on there. And this is going to press fit onto there. Now, it's not always a press fit, but in this case, that's a press fit. That means that this little shaft here is a little bigger than the bore of this, so it will stay in place for the most part. Now you'll see that the shoulder really only contacts the inner race of this bearing. That would be the part in the middle that spins free of the exterior, and that's what locks that on. You can see that this end is threaded, and that when that is pressed on there and the wheel pressed against there, the forces holding the wheel tight to that bearing are this nut and the inner race. That's what holds the bearing in place. So in other words, the hub and the nut press against with this collar against the inner race of that bearing and lock it in that position on the shaft. On this side, there is nothing locking it on. It's just the press fit. And that's what's generally, you don't lock two bearings in place. You lock one bearing in place. That gives the shaft where it won't move. And you let the other one sort of float. But there's also just the amount of play inside of a bearing can also allow for that expansion with heat and stuff like that. Now, the problem I had with this was the bearings were crooked when I got it, and the cap, which you can see has a little shallow ring here, actually only traps the outside of the bearing. There's also a spacer between the two bearings, and so the wheel hub in of itself captures the outer race of the bearing and compresses that into the wheel hub. These are all precisely measured to within a thou. In some cases even more than that. Some might actually be the shaft spacing here is not the same as the shaft spacing here, so that the inner and outer races are forced together. And what that does is that loads the bearings and takes up a bit of play. Now that's usually done in drill presses where we don't want anything. In this case, I think these are the wrong bearings. And as you can see, these bearings are perfectly flat, meaning that the outer race and the inner race are in the same level. I suspect that here's an extended race. This is a new departure 87505, and you can see that on one side the inner race is further out than the outer race. These are usually used in a preload situation such as this. These are of course obsolete, and a lot of people will talk about the extended race and what that's about, and you know, that'll shift off things and sort of generally it was the way of doing things. One thing that most people don't know, or I never see much talked about, is on the other side These races are not even. The inner race is set back in there. Do you see that they aren't even like this one is? And so that can mean that this thing is not the same dimension as the shoulder to shoulder dimension, because it takes into account the different things. Now, when this was given to me, the exterior bearing retainer that went on this side actually wouldn't seat against the hub. This, with these bearings, would not let it compress, and it got stripped. It had stripped, you know, because people want to tighten things down, and it got stripped out. Also, the one thing I noticed was that this looks like an original part. One can see the small little lathe marks. We can see lathe marks cut there. We can see lathe mark cuts there. But when we turn it over here, we can see sanding marks or grinding marks. To me, that's an indication this has been worked with. And when I measure around this circumference, it's out a 1/10 thou in measurement, which is poor workmanship for bearing work. In fact, also, if you look very carefully, and I put these together, you're going to see that the inner and outer rings are not the same dimension. In other words, this spacer will not let those bearings shoulder on that shaft, which is what holds that shaft square. So I believe in this case the 6205s are not the correct bearing for this. It's not to say that that's not the bearing to use, because the 880505s are no longer made, and if they, I believe maybe they are by the Japanese NTN, but Japanese NTN bearings are junk. SKF bearings are better. So to save people in the future, it's best to make the conversion, but make the conversion proper. This, in my opinion, needs to be the same as the inner outer race. If anything, 1/10 thou shorter, so that the bearings here can seat onto this shaft proper, that these outer rings, when attached to the hub, will sit tight on the hub and maybe apply some load to the bearing. I'm going to get a C3 bearing, which has a fair amount of what's called internal clearances, or that little amount of space in between the inner and outer race ball clearances. And so it can take 1/10 thou of compression. Then this will all hold together properly and run beautifully for years. Not only that, the next person that sees these bearings in them can literally look at the numbers, take them out, and replace them. So anyway, I will show you how I will achieve that with woodworking tools and files. You can do work to 1/1000th of an inch with files and sandpaper in this kind of work. This still is not really high precision work. It is and it isn't, but knowing how the system should work is really much more important than the bearing sizes. And you cannot rely on bearing houses without a little bit of knowledge. Generally, the experience at a bearing house would be you'd bring the bearing in that's failed, but you need to look at the things I've indicated. Look at this bearing. That ran so hot that the outer race melted. Okay, a bearing shop should go, ooh, that's running hot. Why? The other thing is the other indications I've showed you. They may only have noticed this, but they didn't notice that the inner race is set back. You know, so there's some very subtle things. Things like, how radiused is that corner edge compared to a modern bearing? You can see this modern bearing is quite radiused. If I tried to use this on a shaft that was not milled, and as you can see, there's a tiny little undercut at the shoulder area. I'm not sure if you can see that. But you can see there's a tiny little undercut. But sometimes that'll have a radius, and it will need those bigger radiuses on the inside of the race. At any rate, I thought I'd share that little bit of knowledge on bearings that I have, and I have very little, but as woodworkers, I think that we need to understand a few things that will be helpful when we are restoring old machines, and that is, not always are the bearings that are in a machine the correct bearings. Thank you.